Alright, so in this video I'm just going to go over quickly how to set up Tracker to analyze a video of a 2D collision. So on your worksheet here it's got a couple of links. It's got a link to the Tracker app and where you get it. So you'll need to download the installer for your operating system and then run the installer, and it should install, and you can click launch straight from there so that it opens. Once installed, you can find it on your computer, so just search for Tracker, and open that. And that's a Java file, so it takes a moment to open. The other thing is I've shared with you a short video clip that is suitable for analyzing for us. So if you click on this link here, you can open that, and it'll open in Google probably by default, but you can click this little download button and it will download to your computer. I've already done that, so I don't need to do that again. Okay, once Tracker is opened, you'll get a window that looks like this. So I'm just going to make that a bit bigger here so that we can see it. Okay, so what we want to do is open our video in this workspace. So we just need to locate it on our computer. Mine's in my downloads folder here. So I'm just going to drag that into the screen. And so here's our video. We can hit play here to see it. We've got the two pucks on an Airtable colliding with almost no external force. So the first thing that we want to do here is just select the part of the video that's interesting to us. And to do that, we just click on this little black arrow on the timeline until we get to the first frame that we're interested in. So I'm just going to choose that frame there. In fact, I'm going to go back just one more frame. And then I'm going to choose where I'm ending as well, because I don't really want all the bits where they're bouncing off the walls of the table. So I'm going to go back until before they've bounced. Maybe about there. Okay, so this is the part of the video that I'm going to analyze. I'm going to click back, and this video was shot at quite a low frame rate, so the frames are a little bit blurry, so we need to choose a point that we're going to track on this video. But before we get to tracking, I'm going to just double check a few of the settings on here. So if we click on this clip settings button, it allows us to see the frame rate, and this video was shot at 30 frames per second, so we can just leave that. That's fine, and it's not a ridiculous number of frames. So in fact there's a total of 25 frames, so that's okay. That's not going to take us too long to track, so we don't need to worry about step size either. Okay, the next thing is to give our program a sense of the scale of this thing. So this is a calibration tools. Click on new and we choose calibration stick. And you'll see you get instructions in this little bar here of how to use it. So we're going to hold down shift, and our mouse turns into this little crosshair. And I know the diameter of this white circle on this block. In fact, I'm just going to zoom in a bit so I can see what I'm doing. So I know that the white circle here has a diameter of about 8 centimeters. So that looks about right, and I'm going to write that that's 0.08 meters. And then I'll zoom back out so I can see the whole thing. And I'll just move that out the way so it's not going to get in the way of what I'm doing. The video now knows, the program now knows how large everything in this frame is at that depth. So it should be able to compute distances, and it understands time because it knows the frame rate, 30 frames per second. So between each two frames, 1/30th of a second will pass. Alright, so now it knows scale. I'll give it an origin as well. So I'll click these axes, and I just want to tell it where x and y is 0, and I'm going to decide that that is at that point. And then I can hide that again. It still sits in the same place, but it's hidden so it doesn't get in the way. Alright, now we're ready to track our disks. So I click create here, and I create a point mass, and it's called mass A, and I'm going to decide that this mass that's initially moving is mass A. Now it's blurred, so I need to decide on a point that I'll be able to identify in each frame, and I'm going to choose the forwardmost point of this. this center line is blurred. So here you can see what it looks like when it's stationary. but here it's been blurred out. I'm going to choose the point that's furthest forward in each frame. So I'm going to click there. And now they've collided, so it's changed. I'm going to stick with the furthest forward part of that line. And just a couple more frames. And I think that's the last one. Maybe I'll just click that final one as well. Okay, so now what we can do is just have a look at this. So we can see it moving, and that's the track of its motion. And we're going to do the same thing for the second one. So we're going to create a second point mass. It's going to be called mass B. And with mass B, we're again going to hold down Shift and just click on the thing each time. So I'm going to zoom in once more so that I can see what I'm doing. And I'm going to click on this mass. So it's not moving at the moment. Okay, so now it's just about to start moving. And I'm going to stick with my plan of always going for the part that's the furthest forward in the direction of motion. Until I get to the final frame, which is coming up right about now, the 20th frame. So now I've tracked the motion of both. I can watch how that happens. So we can see the path of both of the objects. Okay, the next thing that we can do is we can add a track of the center of mass, and we can do that automatically if we just click Create here and we choose Center of Mass, and we just tick our two masses. Okay, and now we can watch what happens to the center of mass during the collision, which isn't much. One thing that we do need to do is, because we're going to be working with momentum, we should really tell the program how massive these two things are as well. And they're about 50 grams each, so I'm going to go to Define under mass A, and instead of 1 kilogram, I'm going to change that to 0.05 kilograms. I'm going to do the same for mass B. So you can see now that I changed mass A but not mass B, the center of mass is now sitting right next to mass B, and that's because mass B is still a kilogram. So I'm just going to change mass B to the correct mass as well. So all I did there was double click on where it said 1, and that gave me the option to change it. Okay, so now we have the correct masses, the correct scale, we've tracked all the objects. Now we can get to the interesting part, which is analyzing the motion, and that's what the task sheet is all about. So it gives you pretty clear instructions, but I'm just going to show you a couple of things that you need to be aware of. So when we're working with the graph here, we can minimize other stuff by just using these little blue arrows. We can get that stuff back by just clicking the other arrow. So this graph is currently showing the horizontal position X of the center of mass, and we can see that has a negative gradient, so it's moving to the left in the negative X direction. But what I'm going to do is go back to mass A, and we can see that mass A moved in the X direction first quickly in the negative direction and then more slowly in the negative direction. That's not particularly interesting. We can look here at the horizontal momentum. We can see that the horizontal momentum starts off with a big negative value, and then in the collision the momentum changes and the horizontal momentum becomes smaller. We can look at the vertical momentum, and that sort of does the same thing, except it starts off slightly negative, so it's moving slightly downwards to begin with, and then afterwards it's big and positive because it ends up after the collision. So we can look at how the graph here relates to the motion in the window. If I click forward here, you can see that the red object now changes direction, and then it ends up with a large vertical momentum. Okay, so that's how the graph works. We just click on the vertical label and we can change to other quantities. We can also define our own quantity, and you'll need to do this when you come to the point where you want to graph force, because net force is not on here. So to do that, you just click this define button, and you can write in your own function. All right. One last thing to be clear on, and this will be the last thing that I'm going to explain in this video, is that we're often interested in looking at vectors. So especially in this case. So if we click on this V button here, now it'll show the velocity vector for each frame. I'm going to get rid of the trails so that we don't end up with too many vectors. So here you can see a velocity vector, and if you click on that vector, you can see its size. So this is its horizontal component is negative 0.6 because it's moving to the left. Vertical component is negative 1.662 times 10 to the negative 2. So it's moving ever so slightly downwards. The total size of the velocity is this, and this is the angle of the velocity. Okay, however, the vector is kind of small, so we can't really see what's going on with it. So what we can do is just scale it up by clicking this stretch button. So I'm going to scale it up 6 times so we can really see what's going on with the velocity. So now we can see that the blue one has pretty much 0 velocity, the red one has a big velocity, and the center of mass has a velocity in the same direction as the red one. If I click forward here, we can see that in the collision, the second mass gains velocity, and the direction of the velocity of the first one changes as well. Now, so that's the velocity. If we want to look at momentum vectors instead, we can just click this times m button. That'll multiply the velocity by mass. So you can see all the vectors have now changed to p for momentum instead. So we can look at what's going on with momentum in the collision. So we start off with that momentum, and then after the collision, the momentum of the individual pucks change. Similarly, we can look at force vectors. If we click on the acceleration and we leave this times m on, you can see it now says net force here. And I'm going to again stretch the acceleration vectors. I'm going to stretch those 8 times. And at the moment they're not experiencing any force. If I go back to the start, we can have a look at it from the start. I can click through this. No net force really until they start to collide. Then we can see that there is a net force, but only while they're colliding, and then the net force is gone. So there's a force acting only during the collision. Alright, so that should give you some guidance as to how to start. You can then follow the instructions in the worksheet and let me know if you have any questions.